right, welcome. Problem number 3. Are you excited and raring to go? I know you are. All right, once again, in this problem, we're going to be finding the critical points, and we're going to find where we have any local extreme values. All right, and hopefully they occur at these critical points. But we're going to go through the process and identifying these critical points, extreme values, and then using our calculator to determine what if they are actual local mins, maxes, or whatnot. Okay, so first off, we go through the process, and even though it just says find the critical points, I like to always go through the mental process saying, I'm looking for local extreme values. Where do they occur? They occur at endpoints and at critical points, which are the interior points. Okay? So you heard me write this down 10 billion times. That's what we do. Now, in this particular equation, do we have any endpoints? And the answer is none. Okay? Because we do not have a domain, all right, anything over here that restricts it. There is no closed interval, so there is no endpoints to this particular function, at least that I know. Now we look at the critical points. Now, remember the critical points? You've seen this several times now. F prime equals 0. F prime doesn't exist. All right. Now, in this case, we're not dealing with F. All right. So I'm going to change this up. Maybe you caught this as well. All right. But it should be Y prime and Y prime. No, it doesn't exist. So we'll find out our derivative for this particular function. All right, so we can find our critical points. So we know where some absolute maximums could occur. So we're going to take the derivative of this. And by doing so, all right, I'm going to use the product rule. Or actually, we could maybe factor this through first. Maybe factoring it through might work out a little bit better. All right, when we have this right here, I can have x to 2/3 times x squared minus 4 times x to 2/3. From here, I can get a common down, which is 3, so it would be 6, would be 8/3, and minus 4x to the 2/3 power. Okay. Okay, that should be what our y value is. Hopefully I did that right. Y equals 3, 6, 8, yeah, okay. Now, from here, all right, now we're going to find that y prime. I'm going to use this one instead of using the product rule. All right, algebra is my friend. That's all I have to say. All right, we take the derivative of the first, which is 8/3. Times x, subtract 1 from that, and we have 5/3. Well, now we go over here, and we say minus, and now we're going to have 4, all right, times 2/3. Okay, so that would once again be 8/3. Okay, 8/3, x to the negative 1/3 power. Okay, from here, okay, we're going to simplify this to make it a little bit nicer. And we can see that I can factor out an 8/3. And then I have x to the 5/3 power, and I have minus, all right, 1 over x to the 1/3. Okay, we're going to simplify this a little bit farther, okay, because this, remember, is y prime. And I'm going to get a common denominator, so I'm going to multiply this right here, on bottom, by x to the 1/3. Right here, x to the 1/3, minus 1 over x to the 1/3. We still got the 8/3 just hanging around, come along for the ride. When we have this, we add those together, and we have x squared minus 1, because 5/3 plus 1/3 is actually 2, all right, or 6/3, which is 2. And minus 1, and we get all over x to the 1/3. All right, all times 8/3, and that's our y prime. So once we have our derivative, which is located there, we're going to find our critical points. So when does y prime equal 0? Once again, you take the numerator and set that equal to 0. So we have x squared minus 1 equal to 0, and x is going to equal positive negative 1. Okay, so those are my possible critical points. These are my critical points, but these are possibly my extreme values. So now I go over here. I keep on using f. Don't do that. I'm going to plug these in here to find out my actual values. So I'm going to have y of negative 1 and y of positive 1, and I plug that to the original function. And I go up here, and actually I'll carry this down because I need you. Come with me, come with me. All right, I'll make that a little smaller, so put in a little space, whoop, right there. Okay, so now that I have my original function just hanging around, I can plug into negative 1. All right, we get negative 1, and it's going to be squared, so it'll be positive 1, cube root of it, which is going to be 1, times, then we have negative 1 squared, which is 1, minus 4, so that's going to give me negative 3. All right, so we have 1, all All right, value of negative 3. I plug in 1. Once again, we get 1 times 1 minus 4, which happens to be, once again, negative 3. Hey, the same values. Now, relative max and mins can have the same values, just means they might not be, and they share maybe possibly being absolute max and mins. All right, that's kind of interesting. All right, let's look at some other values. We also want to look at, for our critical points, and remember this, is when y prime, and I'll use a different color, I'll use green, when y prime doesn't exist, all right, where it's undefined. And that's where we look at the denominator and set that equal to 0. Well, in this case, you can see that my denominator right here is x to the 1/3. I'm going to set that equal to 0. All right, and that's right there. So I find out x equals 0 when that equals 0. And so now I plug this in here, y of 0. Well, y of 0, I plug 0 in there. 0 times anything is 0, except infinity, but it's a totally different topic. But that is our other value. All right, well, it appears, all right, just by, if I would understand this, this, what I'm guessing, probably because it's larger than the other ones, if this is a relative, it'd probably be a relative max, I'm guessing. Okay, because this value is larger than the other two values. These would probably be relative mins if I were to make an educated guess just by looking at the values. To figure out the actual values, there is other analysis, and we're going to learn about this, all right, in future lessons. All right, but for right now, to identify what they actually are, we're going to actually go to our calculator and punch them in and identify what the graph is. So I already did that right here. And here's the graph of that function. And you can see that while we did figure out where these were located, all right, through our critical points, we did identify at -1 and 1, we have values at -3, which are actually relative min and maxes. So these right here do match up. Awesome. So that makes me happy. All right, we also then can look at our relative max, which we can see is a cusp at this point. Pretty awesome. And that was where our value was undefined. Okay, and that was our max. All right, and which is another cool thing, a little tongue. All right, and that's what we have. So we identify our relative min and maxes by finding the critical points. Make sure that we identify where that derivative equals 0 and also where it doesn't exist, because where it doesn't exist is really important because you might have corners or cusps that you haven't thought about. They're not always the vertical asymptotes that we've seen in other problems. Okay, well, I hope that helps out. We're going to go through one more. There's going to be one more video, so you can copy this down and write this out and replay it. I'll put this on YouTube for everybody to enjoy.